This lesson concerns variation. You will find that there are several types of variation, one which we call direct variation and another which we call inverse variation, and then there will be a third type that we will refer to as joint variation. I want us to look at an example that will help you to understand exactly what we mean by a variation problem. Tennis shoes are on sale for $40 a pair. What is the relationship between the number of pairs of shoes P and the cost C? What I want to do is to set up a table here to look at this relationship. Let's use one line for P, the number of pairs of shoes, and a second line C for cost. And what we're going to do here is to see if we can determine what's happening as we change the number of pairs of shoes. Let's start with, if we choose to buy one pair of shoes, what will our cost be? Well, if the shoes are $40 a pair and we buy one pair, our cost will be $40 then, won't it? Okay. What if we choose two pairs of shoes that we're going to purchase? What would we do to get the cost? Well, of course, if I buy two pair of shoes and each cost $40, then to get the total cost here, I would multiply 2 times $40 and get $80. And then moving on up, if we purchase 3 pair of shoes, 3 pair of shoes at $40 a piece, what would I do to get total cost? Again, wouldn't I multiply the number of pairs times the cost? 3 times $40 is $120. Of course, we could do other examples, but this same relationship will exist. If we were to write an equation relating the cost and the number of pairs of shoes, our cost is going to equal $40 times the number of pairs of shoes. And of course, in algebra, when we write multiplication, we don't put that dot or anything in there, we just write 40p. I'm going to leave that dollar sign off because we're just going to understand that that dollar sign is there. So what we have here is that the cost is a multiple of the number of pairs of shoes. It is a simple number times the number of pairs of shoes. When we have a situation similar to this, we call this a direct variation. The cost is directly proportional to the number of pairs of shoes that we purchase. And you'll find in this definition that we can use the words directly proportional to as well as varies directly. A direct variation or proportion then. We say that y varies directly as x, or y is directly proportional to x if y is equal k times x, where k is a constant called the constant of variation or constant of proportionality. So if we have y equals a multiple of x, k times x, this k, this constant, is our constant of variation. In our problem we looked at a moment ago, we had that cost is equal to a constant times p. This constant, 40, is our constant of variation. And of course we can see then that cost is a multiple of p, 40 times p. What we want to do is, when we have problems that tell us that we have something varying directly, or it may say is directly proportional to, then we know we can write an equation that looks like this. And we will start with that equation to solve our problem. Let's take a look at an example. Y varies directly as x. If y equals 210 when x equals 7, find k, the constant of variation. I want to call your attention to this first sentence right here. Y varies directly as x. From our definition, that means y equals some constant k times x. So we know our equation should look something like this. Then what we're going to do is, using the given information, we're going to substitute into this equation to find k. So if y equals 210, we will replace 210 for y. We do not know k, let's put that down, times x. We were given that x is 7 whenever y is 210, so we have this relationship here. Of course, to solve this equation, I would divide both sides by 7. 7 will divide into 210 30 times. So my solution is k equals 30. My constant of variation is 30. What that allows me to do then is to go back to this equation that I knew I had and rewrite it now, since I know k is 30, as y equals 30 times k. I want to show you another example that is very similar to this one, but you'll notice the wording is slightly different. Y is directly proportional to the square of x. If y equals 3 when x equals 6, find the constant of proportionality. Now, this directly proportional is another way of saying y varies directly as. So you may have that worded several different ways. Notice here, y is directly proportional to the square of x. Y is, of course, is always equal. So y equals, if we have directly proportional to or varies directly as, we need a constant of variation k times what we are proportional to. We are proportional to the square of x. The square of x means x squared. So I know my equation should be y equals some constant k times x squared. Y varies directly as the square of x, or y is directly proportional to the square of x. This idea of varies directly or is directly proportional to is what tells us to have that constant of proportionality there. Now, if y equals 3, let's put that in for y. Whenever x is 6, put that in for x. Notice we're going to have to square that. We want to find this constant of proportionality. Of course, we need to square this first. 6 squared is 36. I'm going to go ahead and write that as 36k, since multiplication can be written in either order. Now, again, to solve for k, we need to divide by 36. So dividing by 36, we have k is equal 1 over 12 here. And so now my equation would be y equals 1/12 times x squared. You'll notice in these examples that we were told that we had a proportion, a direct proportion, or a direct variation, which told us the way our mathematical model should look. Once we had that model written down, then we substituted information that was given in the problem, which allowed us to find that constant of proportionality. What we're going to do in the next example is to take that another step and find another missing quantity. Let's take a look at that example. Y varies directly as the cube of x. If y equals 80 when x equals 2, find y when x equals 4. Now, let's concentrate on this first sentence right here first of all. Y varies directly as tells me y equals, and I need a constant k times something. Times what? The cube of x. The cube of x means x cubed. So my equation in general is going to be y equals a constant times x cubed. That gives me my direct variation. Now let's substitute in. If y equals 80, whenever x equals 2, I have 80 equals k times 2 cubed. This, of course, will allow me to find k. Let's cube that 2. 2 cubed is 8. So my right-hand side is 8 times k. Then we will divide both sides by 8. And I have 10 equals k. Now remember what that tells me. Go back up here. I now know y equals 10 x cubed is my model. Now, if I want to find y when x equals 4, I can just substitute x equals 4 down here. Y will equal 10 times 4 cubed. So, do you know what 4 cubed is? If you're not sure, then you could multiply that out. 4 cubed is 64. 4 times 4 times 4 gives me 64. And then, of course, 10 times 64 is 640. So, whenever x is 4, y is 600. Now, what I would like to do is to work a word problem involving direct variation. Hooke's law states that the force required to stretch a spring beyond its natural length varies directly as the increase in the spring's length. If a force of 25 pounds is required to stretch a spring from its natural length of 12 inches to a length of 17 inches, how much force would be required to stretch the spring from its natural length to a length of 20 inches? As we read through this problem, did you notice right here the words varies directly as? This indicates we have a direct variation, and so we know something about the form that our equation should have. Now let's take a look. The force, and he talks about what this force means, the force varies directly as increase in spring's length. So what we need to do is to choose some variables to represent these quantities. Let's do this. Let's let F equal the force. That way it'll be easy for us to remember what that letter stands for. And how about if we let I equal the increase in the length? Now, notice that I did not say length here because it's very important that you notice that it is an increase in the length, not just the length itself. So if the force varies directly as the increase in length, we have F equals some constant K times I. Now, let's look for information. A force of 25 pounds, so that would be what? That would be F, wouldn't it? We know F is 25 here, equals. We're going to be, of course, looking for K. Let's look for increase in length. We stretch the spring from its natural length of 12 to a length of 17 inches. If the spring started out 12 inches and it ended up 17 inches, what is the increase in length? See, we need increase. Of course, we increase by what? 5 inches. We can take the difference here. Our increase is 5. To solve for K, we will divide both sides by 5, and we have K equals 5. That tells me then I can rewrite this equation. The force is equal to 5 times A. Sometimes this constant of proportionality that we have here when we're working with these springs is called a spring constant. So in this particular case, 5 is the spring constant. Now, let's see if we can answer the question. How much force? So we're trying to find what? F. How much force would be required to stretch the spring from its natural length to a length of 20 inches? Well, remember, its natural length was 12 inches. We want to stretch that to 20 inches. How much is our increase here? It's 8 inches, isn't it? So we're going to bring down our constant 5. Our increase I is 8 inches, and so the force would be 5 times 8, or 40. Recall that our force is in pounds. So it would take 40 pounds to stretch this spring from its natural length of 12 out to 20 inches. Now that we have looked at several direct variation problems, we're going to look at a definition of inverse variation, which will be a little bit different than a direct variation. Inverse variation. we say that y varies inversely as x, or y is inversely proportional to x, if y equals k over x, where k is the constant of variation. So what is the difference between a direct variation and an inverse variation? Our direct variation over here had k being multiplied times x. You'll notice for an inverse variation, our k is being divided by x. So we'll need to remember that as we look at these problems. Y varies inversely as the square of x. If y equals 9 when x equals 4, find y when x equals 3. Notice your words here, varies inversely instead of varies directly. So we're going to have y equals our constant k over something rather than times something. What is it over? The square of x. So it is over x squared. Y is varying inversely, so we have k over the square of x, x squared. Now, with the information, if y equals 9 when x equals 4, well, let's substitute. Y is 9 whenever x is 4. So I have 9 equals k over 4 squared. So, of course, 4 squared is 16. To solve for k, we need to multiply both sides by 16, so this cancels out. Okay, let's see, 9 times 16. Well, 9 times 6 is 54. 9 times 1 is 9, plus 5 is 14. So our k is 144. That allows me to rewrite my equation now as y equals 144 over x squared. Now notice we want to find y when x is 3. So y will equal 144 over 3 squared. Y equals 144 then over 9. Well, let's see, can we simplify this? Can 9 divide into 144? If you recall learning one time your rules of divisibility, if you add the digits in this number, 4 plus 4 plus 1, that's 8 plus 1 is 9. If the digits add up to a multiple of 9, then you can divide by 9. So I know this is going to divide evenly. Let's do the division over here. 9 will divide into 14 one times. I have a remainder of 5. Bring down my 4. 9 into 54 is 16. So y equals 16 here. Now I want you to notice something with this inverse variation. Notice that y was 9 whenever x was 4. Okay? When x went down, got smaller, what happened to y? It got bigger. Usually with an inverse variation, this is what you're saying. As one variable gets bigger, the other one is going to get smaller. And if you look at this, it's kind of obvious why. If you're dividing k by x squared, the larger x gets, wouldn't y get smaller because our denominator would be getting bigger? And then, of course, vice versa. Let's take a look at another example. A student's grades vary inversely as the number of hours that he spends watching TV. If Joe watched TV for 12 hours and made 15% on a test, what would he have made if he had watched TV for only 3 hours? Notice again, a student's grades vary how? Inversely. So let's do this. Let's choose G for grade. And let's use H then for the number of hours that we watch TV. Our grade G varies inversely as, so we need a constant over the number of hours H. This is our basic equation. If Joe watched TV for 12 hours, that's H. So I know K is over 12 here. And when he watched TV for 12 hours, he got a grade of 15%. Let's put 15 over here, and we'll remember it's a percent. To solve for K, I will multiply both sides by 12. This cancels, and I have K. Now let's see. I need 15 times 12. 2 times 5 is 10. I'm carrying 1. 2 plus 1 is 3. And then 1 times 5 and 1. So I have 180 for my K. So my equation now is G equals 180 divided by H. Now for our question, what would he have made? That means we're looking for what? His grade. So his grade would be 180 over how many hours? He watched for only 3 hours this time. Okay, so his grade would be 180 divided by 3, which of course is 60, and we recall that's in a percent form. So he would have made 60% rather than 15% had he watched TV for only 3 hours. There is one additional type of variation that we're going to look at, and that is called a joint variation. Now, when you have a joint variation, what that means is that you have one quantity that is varying in relationship to 2 or 3 or more quantities rather than just one other quantity. Let's take a look at that definition. Joint variation. We say that y varies jointly as x and w if y equals k times x times w, where k is the constant of variation. Notice jointly as two different things. So we have our constant times 2 other variables here. Let's take a look at a problem where we use this idea of joint variation. A joint variation is just putting either two direct or a direct and an indirect or inverse variation together. Let's look at this problem. Y varies jointly as the square of x and w. So y varies, y equals, since this is a variation, we need a constant of variation, a k. What does it vary jointly as? Square of x is one of those, so times x squared, and then also w. So my equation is going to be y equals the constant k times x squared times w. Now, we're told y is 90 when x is 3 and w is 2. So y equals 90. That will be k times x is 3, so I have 3 squared, times w is 2. Let's find our k. I have 90 equals k times 9 times 2. Recall we do exponents first. 90 equals 9 times 2 is 18 times k. Dividing both sides by 18, I have k equals, let's see, won't that be 5? So again, I can rewrite my model. Y equals 5x squared w. Now, we want to find y, so y equals, whenever x is 5 and w is 4. So I have 5 times 5 squared times w is 4. Doing my exponent first, bring down your 5. 5 squared is 25, and then times 4. Now remember, we can multiply these in any order. Let's do these two first. Y equals 5 times 100. You see why I chose that? That's easy, isn't it? So y equals 500. So if x is 5 and w is 4, y will be 500. I have one additional example that I would like to work for you. This is coming from a chemistry application. The volume of a gas varies directly as the temperature and inversely as the pressure. When the temperature is 750 kelvins and the pressure is 15 pounds per square inch, the volume is 150 cubic inches. Find the volume when the temperature is 450 kelvins and the pressure is 18 pounds per square inch. Now this problem is telling us that if you have a gas, most of us know that if you heat a gas, it expands. If you increase pressure on a gas, it will contract, it will be smaller. So both temperature and pressure will affect the volume of this gas. Now let's see if we can write an equation. You'll notice here he does not use the word as in terms of a joint variation, but notice this, it varies directly as one thing see that word and? Inversely as something else. So we have two variations. That's a joint variation. We're going to put these together. So our choice, let's see for letters. We're talking about volume, so let's choose V to be volume. We're talking about temperature. Let's let T be temperature. I'm going to abbreviate temperature. And then pressure, so let's let P be pressure. By choosing those letters, it makes it easy to look in the equation to see what each one represents. Now, our volume is varying as these others, so our volume is going to equal. We need a constant of variation, right? So we're going to put a K here. It varies directly as temperature. That means we're going to multiply this constant times temperature. Inversely as pressure means that the pressure is going to go where? In the denominator. Remember, with an inverse variation, what you were varying inversely with respect to went to the denominator. So I'm going to put this over the P. Remember, with a joint variation, we only needed one constant of variation. So here, our volume is varying jointly as temperature and pressure, but it's directly to temperature and inversely, so over pressure. Now, let's see if we can use information to find our K. When the temperature is 750 kelvins, pressure is 15 pounds per square inch, volume is 150. Well, let's start with V. Volume is 150. Let's put that in. Equals K times, we're looking for temperature. What was the temperature? It was 750. Over our pressure, the pressure was 15 pounds. Now, let's see if we can reduce over here before we do this division or multiplication. Let's see. Will 15 divide into 750? I believe it will. Let me pull this down. 750, we're dividing by 15. How many times will 15 go into 750? Will that go 5? 5 times 5 is 25. 5, 6, 7, exactly, right? And so then I have that 0. So 15 will cancel into 750 and leave a 50. So I have 50 times K. Now, dividing both sides here by 50, K is going to equal what? 3. So now I can write my equation over as V equals 3T over P. I'm going to pull that down right here. Now, we have a question. Find the volume. So I'm looking for V. I know my K is 3. When the temperature T is 450, let's put that in for T, and the pressure P is 18. Okay, well, let's see about getting our solution here. Since these are factors, I know 3 can cancel into this 18 and leave a 6. So let's do that first. And then it will be easier to divide. Will 6 divide into 450 evenly? I believe it will. 6 times 7 is 42, remainder 3, and then 6 times 5 is 30. So 6 into 450 gives me a volume of 75. Recall that was in cubic inches. This concludes the lesson on variation. Recall there's a direct variation where you are multiplying your constant of variation times your variable. There's an inverse variation where you are dividing your constant by the other variable. And then you can put those together sometimes and have what we call a joint variation. Please rewind this tape before you turn it back into the math lab. Thank you very much.